Hello and welcome to your geometry lesson for today. Today we are covering Chapter 7, Lesson 5, and we're going to be talking about properties of kites and trapezoids. So kites and trapezoids are the two special parallelogram quadrilaterals that we're going to be talking about today. So first, what is a kite? Well, first, we have to say that it's a quadrilateral. When we started with a rectangle or a rhombus or a square, we said it was a parallelogram that has blah, blah, blah. Okay, this is not a parallelogram. A kite does not have the same properties as a parallelogram. A kite is a quadrilateral that has exactly two pair of congruent consecutive sides. So you can see in here that AB is congruent to AD and that BC is congruent to DC. That's what makes it a kite. Now, what are some properties that a kite is going to have? Well, let's draw in these diagonals first. So let me connect A to C and let me connect B to D. Now, I know my drawing is by hand here, but what do you notice about those two diagonals? And if you look at the diagonals, you should notice they're definitely not congruent, because if we look at the length of this side and the length of this side, they do not bisect each other, which is a property that parallelograms have. Okay, so that's another reason why it's just a quadrilateral. But looking at these, don't they look like they are right angles so that they are perpendicular to each other? So the diagonals in a kite have perpendicular diagonals. Okay, another thing to look at, let me get rid of this writing here. And if you look very closely, look at the angle measures of A, B, C, and D. And more specifically, look at the angle measures of angle B and angle D. So angle B compared to angle D. What do you notice about them? Angle B and angle D look like they're pretty close to being congruent. And if you look at angle A and angle C, do angle and C look closer? I would say no. To me, angle A definitely looks bigger than angle C. So this does not work for this, but if you look at B and D, they are congruent. So what happens is one pair of opposite angles in a kite are going to be congruent. So the pair that's congruent, B and D, the other pair, A and C, when you make this diagonal will bisect angle A and bisect angle C. So one pair of opposite angles are going to be congruent. The diagonal is going to bisect the opposite pair. And they don't often tell you that, but it is definitely something that always happens. So the two properties that they do tell us here is the first one I said, that the diagonals are perpendicular. And the second property is exactly one pair of congruent opposite angles. In this particular kite, it is B congruent to D. Now we can also say that diagonal AC bisects angle BAD and angle BCD. So that is a third one that you could say. All right, let's here and try some samples. So find angle D. Well, since there's one pair of opposite congruent angles, we know that it's a quadrilateral, so we know it's going to add up to 360. And 115 plus 63 plus D and F are congruent, so I can call those 2x. I can call this x and this x, and so the two of them together are 2x. All right, let's take 360 and subtract 115 and subtract 63, and I get 182 equals 2x. And now when I divide by 2, I get x to be 91. So angle D, the measure of angle D, is 91 degrees. All right, in kite, so we know that this is definitely a kite. So FEJ, so this is 25. And FGJ is 57. Ooh, tiny angles in here. Find GFJ. Okay, find this angle in here. So that red angle, remember our diagonals are perpendicular. So if we take 90 minus 57, we are going to get that measure of that red angle. So we get 33 degrees. So that is 33 degrees. Now look at that FH. Does that red dot look congruent to this dot? And the answer is absolutely not. Okay, they are not congruent. But that means that the other angles are being bisected. Okay, so if we know this, let's see, what are we trying to find here? I should probably find that first. FJFE. Let me call that one green here. The green one. FJFE. JFE. Oh, they actually want us to find this angle measure in here. Okay, so in order to do that, there's probably more than one way to do this, but we know that in triangle, EFG equals 180 degrees. So if we look at this triangle right here, that is definitely 180. Well, we know one angle is 57, and we know one angle is 25. So when we take 180 minus 57 minus 25, I am getting 98 degrees. That means that this whole big angle is 98 degrees. And we just found the red angle to be 33. So if I subtract 33 from that, what is that? 65 degrees? So that angle that we're looking for is going to be, JFE will be 65 degrees. All right, trapezoids are the other figure that we're going to be talking about today. So notice that the definition of a trapezoid starts with quadrilateral. It doesn't start with the parallelogram. And it has exactly one pair of parallel sides. So you see here we've got BC congruent to AD. We've got one pair of parallel sides. Now with one pair of parallel sides, that means that in this particular case, if we call this 1, 2, 3, and 4, we do not know that 1 plus 2 equals 180. What we do know is 2 plus 3 has to equal 180, because if we're going along the parallels, and 1 plus 4. So those consecutive interior angles are still congruent here. Okay, if we look at diagonals, they're not going to be bisecting each other. Like if we draw this one in and you draw this one in, your diagonals are not congruent. They're not bisecting each other. They are not perpendicular to each other. So the one thing that we have here is from the parallels, B plus A has to equal 180 degrees. Okay, now we also have a special trapezoid called an isosceles trapezoid. And what that happens is the non-parallel sides, if we get them congruent, then that is your isosceles trapezoid. So an isosceles trapezoid is a trapezoid. So it has everything that your trapezoid has, one pair of parallel sides with congruent legs. Okay, and the legs are the non-parallel sides. Legs are the whoops, I spelled non wrong. Got my letters in the wrong order here. That's what I get for trying to talk and write at the same time. Non-parallel sides are called your legs. Okay, and so what happens here, if we have an isosceles trapezoid, what happens here is that your base angles are congruent. Now, what are your base angles? So if these are your parallel sides, the base angles are the angles right on the same side as one of the parallels. So those would be considered base angles. And here's another pair of base angles. And your base angles are going to be congruent. Okay, now in just a regular trapezoid, we can see above those diagonals were not congruent, but if we get these legs to be congruent, now when you make your diagonals, now they will be congruent. Okay? All right, one pair of congruent base angles. Okay, so the base angles are congruent. All righty. So legs are congruent in a trapezoid, base angles are congruent, and we get our diagonals congruent. All right, let's put this to work now. Alrighty, find the measure of angle y. Okay, so we cannot use parallelograms. Opposite angles are not congruent, but we do know that because these two sides are parallel, we know that these two must add up to 180. So if we take 180 minus 117, we get 63. And then we get base angles congruent. So x and y have to be congruent. So y is going to be 63 degrees. All right, to make this isosceles, what would happen? Our base angles have to be congruent. So 2y squared minus 25 must be equal to y squared plus 24. Okay, when I'm getting my letters together, I always like to move my smallest one so that it stays positive, and then I'm going to add 25 to both sides. So it looks like I get y squared equals, and what do we have, 49. So now I'm going to square root both sides, and remember technically this answer is a plus and minus 7. So find the value of y, and since we'd put this in here, y squared, we can actually use the 7 or the negative 7 because we square it so it turns positive. So that is our answer, a plus 7 and a minus 7. All right, the last thing we need to talk about is trapezoid's mid-segment. So this one's going to be very similar to your triangle mid-segment. So mid-segment, this blue one is your mid-segment. So notice it's the midpoint of this side and it's the midpoint of this side, and we connect them. So what happens is all three of these lines are going to be parallel. That blue one will also be parallel. And if we call this 8, then when it's saying the length is 1/2 the sum, so if we call this 8 and this 10, this one in the middle the blue one has to be 8 plus 10 divided by 2, which comes out to be 9. Okay, so that blue segment will be parallel if it's the mid segment, and it is half the sum of the bases. So in this one right here, if I call STX, I'm going to go x plus 38 divided by 2 has to give me 31. So x plus 38, if I multiply both sides by 2 and get 62. And now I am going to subtract, so I'm going to take 62 minus that 38. And so x is 24. So this side ST would be 24. All right, find the value of n. Well, the bases, so when we add the bases, n plus 3 n minus 5, and when we divide that by 2, we have to get that mid segment, which is n plus 6. So I'm going to combine my like terms on top. 3n plus n is 4n, and 3 minus 5 is a negative 2. And at the same time, I'm going to multiply both sides by 2. So I get 2n plus 12 by using my distributive property. So now I'm going to, let's see, I like to move my smaller variable first. So I'm going to subtract 2n. Then I'm going to add 2. So it looks like I get 2n equals 14. Divide both sides by 2. And it looks like n must be 7 in order for this to work. And we know this is the mid segment because you look here and we've got double marks, so that's the midpoint. We know that's the midpoint. That makes this the mid segment, and that's why we can set up our first equation. All right, it is now ready for your homework. So good luck on your homework for lesson 7-5.